How do you solve the given crazy looking exponential equation? So again, the way you want to approach it, you want to make sure that you understand how you're going to use exponents, right? How these exponents in the numerators and denominators respectively relate. And don't worry that you see square roots, right? These are not as scary as they look, and I promise you that. Just watch this video to the end and you're going to get a good feel on how to do this. Okay, so the way you want to proceed, you're going to write 5 to the x squared, and then you're going to distribute the squared. We know from the laws of exponents that the square assigned to fraction means that both the numerator and the denominator receive that square, right? So it's going to be 1 squared divided by 5 to the x squared as well, right? So we distributed this square to numerator and denominator. Okay, so now that's set equal to, and again, the x is a power that is assigned to both the numerator and denominator, right? So essentially 1 to the power of x divided by the denominator, and denominator is square root of 5, right? Raised to the same power of x. So now what happens? Now that you did that, you can multiply out the numerators, because secretly you know that this is divided by 1, right? So that means the numerators multiply and denominators multiply. So this turns into 5 raised to the x squared divided by 5. Now here's the thing. How are you going to write this? This is the power of a power, right? When you have something raised to the power, in parentheses and outside there's a power, that means the powers simply multiply. They don't add. Be sure you understand. They don't add. And the way to tell the difference is when you see the base only once, right? There's only one expression with a base and exponent raised to the exponent outside of it, right? So that's when the exponents multiply. They don't add. So now this turns into 5 2x, right? Because the exponents multiplied. X times 2 is 2x. So that's equal to, now how do you express? So 1 to the x is simply 1, right? As long as x is a finite number, any number except infinity, right? Infinity is not a number, except as long as x is a real number, 1 to the x is always going to be 1, right? So 1 divided by, now square root of 5 can be expressed as 5 raised to the power 1/2. Be sure you understand that. Raised to the x power. Okay? So square root of 5 is 5 to the 1/2. All right, so let's keep going. So what are we going to have after that? We're going to have, let's copy the left side as it was. 5 to the x squared divided by 5 to the 2x is set equal to 1 over, now powers multiply again here. Be sure you see that. This is the power of a power. So 5 raised to the, so remember, x is secretly divided by 1 here, right? So that means the numerators multiply and the denominators multiply. So this is going to be equal to x divided by 2 for the exponent there. So now you can use another property of exponents, right? When the bases are the same, in this case 5, 1 in the numerator and 1 in the denominator, and they have different exponents, the way you write that is going to be simply 5x squared minus 2x. Why minus? Because there's a division of these bases with different exponents, right? When there's multiplication, the exponents would add, right? But in this case, they subtract because this is a quotient, not a product, right? So 5 to the x squared divided by 5 to the 2x is equal to 5 raised to the power of x squared minus 2x, right? Minus is the division. Now this is set equal to what? Now remember that since 1 is on the top and 5 is on the bottom with an exponent, we can just write 5 raised to the negative x over 2, right? Negative simply means it flips, right? Negative accounts for the flip, right? And remember, you might say, where did the 1 go? The 1 is still there. 1 is secretly multiplied to the 5, right? To this base 5, right? That's when the 1 is. So this 1 is this one here, 1 times. So 5 to the negative, it's not a negative number, be sure you understand. The negative simply means it flips. It may be negative when it comes to the power, but essentially the negative the first hand of its meaning is that it's actually flipping, right? It makes sure that 5 to the x over 2 is on the bottom, not on the top. So now that you did this, it's going to be fairly simple, right? Because when we have the same basis, that's what everyone aims for when they solve exponential equations, right? So when you have the same basis, you can set the powers, the exponents equal. So what I'm getting at is that you can safely say x squared minus 2x is equal to minus x over 2. Okay, and that's going to be simple to solve. You add x over 2 on both sides so that it looks like a standard form equation, quadratic equation. So next what happens is that we get x squared minus 2x plus x over 2 is equal to 0. Now you can multiply both sides of the equation by 2, and this way you will get rid of this fraction, right? So twice both sides of this equation. So that means the 2 applies to every single term on both sides of the equation, right? So what I'm getting at is that we're going to have 2x squared minus 2 times 2x, right? So keep in mind that this applies to every single term, right? And also to the 0, this 2 outside. So it's going to be plus 2 times x over 2 is equal to 2 times 0. So now guess what's going on? The 2's cancel out here. So what we're getting is a simpler equation. We're getting 2x squared minus 4x plus x is equal to 0. As you can see, these two are like terms. So as a result, what we get is 2x squared minus 3x is equal to 0. And of course, you can factor them. You can factor this as putting the x outside and letting inside be 2x to account for the first term, and then minus 3 to account for the second term, 3x minus 3x is equal to 0. So in this case, both factors can be set to 0. So x is equal to 0, the first one, or the second one is 2x minus 3 is equal to 0. In the second case, you have to still keep solving by adding 3 on both sides. And then 2x is equal to 3, so that means dividing both sides by 2 will give you x is equal to 3 over 2. So this may qualify as solutions, but before we say that they do, we have to check them both. Right? So the first check is going to be x is equal to 0 in the original equation, right? So we get 5 and substitute x with 0, right? So 0 squared in the power times 1 over 5 to the 0 squared. So let's see. So this, we're just going to check the left side and then the right side. So 0 squared is 0. So 5 to the 0 is 1, as we know. So that's going to be now 1 squared over 5. Now, well, let's actually take care of that. 1 over 5 to the 0 is 1 over 1, right? So let's actually write that down as 1 already, right? 0 squared is 0, so 5 to the 0 is 1. Any non-zero number raised to the 0 power is 1. 1 times, now 1 over 5 to the 0 is 1 over 1, which is equal to 1. 1 squared, right? That's equal to 1. Now, does the right side equal to 1 as well? Let's check. Let's check the right side. This is equal to 1 over square root of 5 raised to the 0 power. And again, any non-zero number raised to the 0 power is 1. We know, right? Because this is a non-zero number, 1 over square root of 5. It doesn't matter. It can be an irrational number, rational number. It doesn't matter. As long as it's raised to 0 power, it's 1. Right? So this means this checks. This is a solution. X is equal to 0. The second one, x is equal to 3 over 2, is a little bit more difficult to check, but it's worth it. So how do you check this one? 5 raised to the 3 2 squared, right? Because that's the power of 3 over 2, and it's squared. So 3 2 squared is 9 4, right? 3 squared over 2 squared is 9 over 4 in the power. Times, now what is that going to be? 1 over 5 to the 3 2 being squared, right? And again, I'm going to work on the left side first, and then I'm going to check the right side. So let's see, that gives us 9 over 4 in the power times. Now I can express this as 5 to the minus 3, 2, right? Because I'm flipping it up, right? I'm getting rid of the fraction by basically assigning a negative in the power, so I don't have a fraction anymore. And I've talked about that previously. I've talked about it somewhere right here, right? When we flipped this right side, we made it look like without the fraction. So I'm doing this again, but only with numbers this time. So this is raised to the second power, right? It's still squared. So that's going to be equal to 5 to the 9 over 4 times. Now, the power of power, as we've talked about before in the previous video, make sure that the powers multiply. So if the powers multiply, the 2's cancel out. So as a result, we'll have 5 to the negative 3. Now, now this is not the power of power situation because we have two bases, right? You see two bases. You see the 5 two times. Whereas in this case, when we talked about a power of power, you see there was a base seen only twice, right? I'm sorry, only once, right? You saw this only once and not twice. Right? Just to help you differentiate the situation here. You can make this look like this too, right? Because 5x raised to the second power means 5x times 5x. But then x plus x would be added and then you would still get 2x in that case, right? But I'm helping you differentiate the picture of it, right? You see the base only once and that's how you know the powers multiply. In this case, the powers will add because you see two bases, two of them. Right? It repeats, not just written once like it was in the power of power situation. So that means it's going to be 5 raised to the sum of the exponents. 9 over 4 minus 3. So that's equal to 9 over 4 minus, now what is the LCD? The LCD is 4. So essentially 3 is multiplied by 4 over 4, which is 12 over 4 as a result. So this is equal to 5 to the minus 3 over 4. So this is what we should be getting on the right side in order for this to be called a solution as well, besides the one we found. So let's check the right side. It's going to be 1 over square root of 5 raised to the 3 over 2, the solution that we're checking. So that's equal to what? Keep in mind that this can be written as 1 over, now 1 to the 3, 2 is still 1, right? 1 to any non-zero number is still 1. Now 5, square root of 5 can be written as 5 to the 1/2, right? So let's actually get rid of this parentheses. We don't need it anymore because 1 is already accounted for. So that's going to be 5 over 2. Now remember that the 3 2 power also pertains to the bottom, to the denominator, not just the numerator, right? So this is raised to the 3 over 2. You might say, wait a second, but why is it not negative? It's not negative because we're not flipping anything. Right? Well, the 3 over 2 is not minus 3 over 2 because we're not flipping anything. Right? We're just assigning the exponent that was meant for the fraction to every single part of it, right? The numerator and denominator. We're not flipping anything. Right? So it's still positive 3 over 2, not negative. So as a result, look what happens. This is a power situation, right? Because you see the base only once and you see powers being separated by parentheses. Therefore, this is the power of a power. So the respective numerators and the respective denominators multiply. So this gets us to be 1 over 5. 3 times 1 is 3. And 2 times 2 is 4. So what does that tell you? That tells you that you can express this, and now we can flip, right? Now we can flip. But if you flip, you will essentially have 1 times, now this 1 times is 1 here. And 5 to the minus 3 over 4, right? Because minus 3 over 4 accounts for the original 5 to the 3 over 4 being on the bottom in the denominator. If you want to get rid of the fraction, you have to put this in the numerator, right? 5 to the 3 over 4, 5 to the minus 3 over 4 divided by 1 is going to be this, right? So as a result, 1 times this is equal to itself, right? 5 to the minus 3 over 4. So guess what happened? Both sides check with this solution as well, right? This one and that one. Thus, this is a solution, right? So we can write solution and we can write solution. As you can see, there are 2 solutions here that worked well, and this is, after all, not such a hard example. It's really fun to do. So hope this was helpful and fun to you too. So take care and see you in the next videos.